In this video, we are going to look at the properties of the vector between 2 points. Let's say we have 2 points, A and B. Let me sketch them, A and B. And we're going to look at the vector that goes from A to B. I'm going to write all these as if the vectors were on the plane, just because it's easier to sketch it to me, but this applies also to vectors and points in 3D. Let's call A the vector that has endpoint at A. So A1, A2, let's call this the coordinates of the point A, and B the vector with endpoint at the point B, B1, B2. So these are the coordinates of the point B. Then let's add the axes, X and Y. Nothing particular about working in the first quadrant, just to make the sketch easier. So we have A1, B1 are the X coordinates, A2, B2 are the Y coordinates, and we can consider we already wrote the coordinates of the vector A, and as well the vector B. And then we can notice that we can write the vector AB as the vector going from A to 0 plus the vector going from 0 to B. So we are saying over here minus A, so the negative of the vector that I sketch over here, maybe you can add here in the opposite direction, this is minus A, plus the vector that we call B. So this is B minus A. And if we look at the coordinates, then we have to subtract the A coordinates from the B coordinates. So B1 minus A1, B2 minus A2. And this is the vector that tells us the displacement of B relative to A. So what do we do to go from A to B? In the x direction, we have to take B1 minus A1 steps. In the y direction, we have to take B2 minus A2 steps. So this is I write the displacement vector of B relative to A. Let's see an example of how we apply this for 3D vectors. Let's say we have point A with coordinates -1, 3, 2, and a point B with coordinates 3, K, 1. If A and B are 5 units apart, we want to find the possible values of K. So we want to find the possible values of K so that the magnitude or length of the vector going from A to B, so the displacement vector of B relative to A, is equal to 5. So let's find that vector, and then let's find its length, and let's make it to be 5. So we're going to have 3 minus 1 for the x coordinate, and k minus 3 for the y one, and 1 minus 2 for the z coordinate. So let's square everything so we don't have to deal with square roots. When we find the length of this vector, we are going to have the length square of the vector, we're going to have 4 squared plus k minus 3 squared plus -1 squared, and that's 17 plus k minus 3 squared. So what we want is k minus 3 squared to be equal to 25 minus 17, which is 8. So that means that we want k minus 3 to be either plus or minus the square root of 8. This gives us 2 possible values for k. It could be 3 plus 2 times the square root of 2, or k could be 3 minus 2 times the square root of 2.